Hi, I am Mrs Nancy Gebian and I'm the chemistry teacher for grade 11 American System. Today is Thursday, March 12, 2020. I'm going to start a new section in chapter 16, section 16.3, colligative properties of solutions. The objective of this section is how colligative properties can be explained on a particle basis. First, what is a colligative property? It is a property of solutions that depends only upon the number of solute particles, not upon their identity. Also, colligative properties are vapor pressure lowering, freezing point depression, boiling point elevation. Vapor pressure lowering. Look at figure 1. Part A beaker contains a pure solvent, while part B, a beaker contains a solvent and a solute. There is a difference in the vapor pressure between the two beakers. The vapor pressure of a solution of a nonvolatile solute is less than the vapor pressure of a pure solvent. Why? Formation of solvation shells around solute particles reduces the number of water molecules with sufficient kinetic energy to escape the solution. Therefore, the vapor pressure is lower relative to pure solvent. Molecular versus ionic solutes. Please open your books, page 535, and look at figure 16.12. Particle concentrations differ for dissolved molecular and ionic compounds in water. First, look at the first beaker. It contains glucose. 3 moles of glucose dissolved in water produce 3 moles of particles because glucose does not dissociate. While sodium chloride in the second beaker, 3 moles of sodium chloride dissolved in water produce 6 moles of particles because each formula unit of NaCl dissociates into 2 ions, Na+ and Cl-. The third beaker, calcium chloride in solution. 3 moles of calcium chloride dissolved in water produce 9 moles of particles because each formula unit of CaCl2 dissociates into 3 ions, Ca2+ and 2Cl-. Now discussing the results. Ionic solutes that dissociate, such as sodium chloride and calcium chloride, have greater effect on the vapor pressure than does a non-dissociating solute such as glucose. Also, the decrease in a solution's vapor pressure is proportional to the number of particles the solute makes in solution. So, comparing glucose, sodium chloride, and calcium chloride solution, the calcium chloride solution has the lowest vapor pressure, while the glucose solution has the highest vapor pressure. Freezing point depression is a colligative property of matter. When a substance freezes, the particles of the solid take on an orderly pattern. But when a solute is present in water, it would disrupt the formation of this pattern, and more kinetic energy must be withdrawn from a solution than from the pure solvent to cause the solution to solidify. So, the freezing point depression is the difference in temperature between the freezing point of a solution and the freezing point of the pure solvent. Let's take an example. If calcium chloride and sodium chloride completely dissolve in water, calcium chloride would lower the freezing point more than sodium chloride. Why? Because calcium chloride, it would produce 3 particles, 1 calcium ion and 2 chloride ions, while the sodium chloride would only produce 2 particles, 1 sodium ion and 1 chloride ion. Freezing point depression has many useful applications. First, when salt is put on an icy road, the salt would mix with a small amount of liquid water, and this would prevent melting ice from refreezing. Also, if you mix salt and ice in a bowl, The same process makes the ice colder, which means it can be used for making ice cream. Boiling point elevation is a colligative property. It depends on the concentration of particles, not on their identity. So what is boiling point elevation? It is the difference in temperature between the boiling point of a solution and the boiling point of the pure solvent. How can a solute affect the boiling point? It takes an additional kinetic energy for the solvent particles to overcome the attractive forces that keep them in the liquid. So, the presence of a solute rises the boiling point of the solvent. Let's take an example. When antifreeze is poured into a car's coolant tank, what happens? The antifreeze doesn't just lower the freezing point of the water in the cooling system, it also rises the boiling point. In this way, the antifreeze helps protect the engine from overheating in the summer.